Okay. So data visualization is basically um, representing the data in form of figures or something. So now why this becomes very important is because when someone see any text or some numbers, so people are means 99.99% people are not able to even remember the number or picture or text for even 1 minute. That is a general human tendency. But if someone sees a picture, so picture stays in a mind for few minutes or maybe for few hours. And but when someone sees something in form of movies and also you know we remember movies for many days or sometimes we remember the movies for many years, right?
Mhm. Yes.
So why do we remember these things for a long time? Because this is the human mind process. So human mind process visual inputs much more better and faster than any other type of inputs. So and also when you see a picture, you can depict about the topic more than you read about something. Correct. So for
Yes.
human mind, it is very much easy for people to process the images in comparison to how it processes the text. And the books which are in form of infographics or videos which are in form of infographics, they get more than 12% more traffic than average, right? And 60% of population is visual learner, 30% is auditory learner, and only 10% is which is kinesthetic. Kinesthetic means who can remember the numbers, who can remember the text. Rest, most of the population is the visual learner. So that is the reason when someone represents something in form of numbers and all, it becomes less expressive rather than when in form of graph it is talking. And by seeing the graph, even a person who is unknown for mathematics or unknown for the business or unknown for any process, but if he or she see graphs, so it can understand even without some description also, right? So this is why the visualization becomes very important, right? Now, for visualization in Python, there are different packages are there. So one of them is matplotlib, then cbun, bokeh, plotly, ggplot, pegal, gleam. All these are the visualization related packages are there. Okay. So if you have to install the package, so simply you have to use this command pip install, basically pip install cbun, matplotlib, bokeh, plotly. So if these packages are not there, you can try installing this. So if it is there or not, simply you can just write these commands: import numpy as np, import pandas as pd, cbun as sns, matplotlib as mat, and bokeh. Right, so just execute this. So if there will be any issue, it will throw the error here itself. If there is, if everything is all right, so it will not give any issue over here. Okay, so by this you can check whether these graphs are available um, in your Jupyter or not. Okay, if not, then just execute this command and it will get executed, and you will get all these packages. Now, types of plotting, there are different types of plotting is there. One is univariate, then bivariate and multivariate. So what is univariate? Univariate is the one where analysis of one variable is given. Only analysis of a single variable is given. Then we call it as univariate. So in univariate, we have bar chart, we have line chart, we have area chart, and we have histogram. These four things are there. So bar chart, line chart, and area chart are almost same. Okay, bar chart, line chart, area chart are almost same. In bar chart, if you connected the top points of each bar, if you represent, it becomes the line chart. And under the line chart, if you color everything, that becomes the area chart. It is as simple as that. And histogram is used for numeric data. So bar chart, line chart, and area chart is given for the categorical data, while histogram is used for the numeric data that is under the interval. Is it clear?
Yes.
Is it clear?
Yes. Yes.
Okay. Now, now we have two files, Wine1 and Wine2, and these two files have. I am just importing these file pd.read underscore csv. I am just importing these two files. So let them get imported. We'll see very small implementations so that you will be able to understand how these things are being processed. Okay, so these are imported. Now see wine one shape is 75,465 and 10 columns. In the in wine two, there are again same. And now I am combining these two files into one together. And in reviews, we have 1,50,930 records are there with 10 columns. Okay, let's see the top five rows. So we have country, description, designation, points, price, then province, region 1, region 2, variety, and binary. These all are the 10 columns. Okay. Now we'll start one by one. We'll start first of all, we'll take bar chart. So what is bar chart? Bar chart will take based on the province area, right? How many wines are there from which area? We are just going to take we are just going to identify this. So we are taking the bar chart. In bar chart there is a review, province, value counts, and head. So what this will represent, basically value count represents the unique value in this column, right? So in reviews table there is province column is there. How many unique values are there, it will represent this. So there are provinces are there. It will find the number of unique values, and out of them, top 15 rows will be taken, right? So if I don't give this, so what it will do is it will find the unique value. So there are 455 unique provinces are there in this. Okay, out of that, California has alone 44,000 provinces, then Washington has 9,700. So California is itself a biggest producer of the wines. Okay, now I am just taking the top 15 only. So I am giving just head of 15. So you can see here, it is giving me the top 15 values of wine producers. And just after this, what I'll do, I am just adding this plot dot bar. So whatever it is showing here in the table form, the same thing it has presented in the graph form. I have just added this plot dot bar over here. Okay, is that okay?
Yes.
Okay, so this is very simple. And then from this, what we can infer is that California produces far more wine than any other province of the world. So you can see here, it is almost producing almost one third of the wines. So there are 1 lakh. How many records are there? 1,50,000 records. Out of that, 44,500 records, almost 30% are produced in just by California only. And I am just plotting a bar. So in bar also, California is more than uh, much higher than anyone else. So after California, the top is around 9,000, but here it is alone. This is 44,000. Okay. So now next we'll take the review column. So in review, no, not review, sorry. Now, what I'm going to take is I'm just going to find out the percentage. Percentage of what? Like how many percentage of wines are produced in California? What is the percentage of wines in Washington? What is in Tuscany? Like that. So what we are going, first of all, we are trying to find top 10 and then divided by length of reviews. So how many length is 1,50,000 records. So out of 1,50,000 records, California has 44,000 records. So 44,000 divided by 1,50,000. Okay, then 9,000 something divided by 1,000, 1,50,000. So that's how you will get the percentage of them here. So you can see California has around 29%, Washington has 6%, Tuscany has 4.8%, Vodex has 4%, North Spain has 3%. Like this, it is going down. Okay. So now when we plot a bar plot, just after this, I am writing this plot dot bar. So the same thing is represented in this as well. Okay. So is this easy, clear?
Yes.
Okay. So now next we'll take another variable. That variable is point variable, right? So first of all, how many unique values are there in point? We'll try to figure out. So review dot points and unique. So it has given that we have 96, 95, 94. So basically it is starting, the smallest point is 87. After that 87, and sorry, 80. Smallest point is 80, then 81, 82, 83, 84, 85. So there is no point less than 80. So 80 is the minimum point. Now we'll see how many wines are there for each. So I am just doing review points dot value count. So for individual points, it will tell how many values are there. So 20,747 wines have 87 points. 17,871 has 88 points. In the same way, you will see that 24 wines has point 100. 50 wines has got point 99. So I'm just representing this. Now you can see this. These figures are in descending order in form of number of counts. You can see here the index that is being used is not in sorted order. So 80 is the minimum, it is coming here. What I want is the 80 should come, means it should come as the index sorted wise. So 80, 81, 82, like that it should come. So I'll just implement sort underscore index over here. Okay, just I'll mention sort underscore index. So you can see now here it is starting from 80 going till 100. Okay, so in this way, you can do this sorting as well. And now what I'll do is I'll just, after this, I'll use plot dot bar. So you can see here, we have used this plot dot bar over here. So now from 80 to 100, it has placed this bar. Okay, this bar is created now.
Okay.
Sorry,
Yes, yes.
are you asking something?
No, no. No, I'm not asking. I'm saying yes.
Okay. So understood this, how we can sort the index wise?
Yes.
Just we
Yes.
have to use this sort underscore index. Okay. Now, the same thing we will implement using the line chart. So instead of this bar, we'll use line. So you will get plot dot line over here, and same thing is implemented using line. Okay. And in the at place of line, if we use area, so we'll get the area chart. Okay.
Okay.
Okay, so this is very simple, and you don't need to think much about bar, line, and area. Just mention the function name, and it will make the entire visualization of univariate according to that. Clear?
Yeah. Yeah, clear.
Okay. Now, mm, in this area chart, mm, what we have reviews, points, value count. So. Next is histogram. So till now we were using the reviews and we used the province. So province was the character variable and the review was categorical variable. Okay. So for categorical variable or for the character variable, we use either bar plot or line chart or area chart. But when the value is numeric, so in numeric, what we'll do is when we have to represent the numeric in chart, we make them in form of intervals, right? So when intervals are there, it will be represented in a histogram. Okay, so here you can see I am taking price. So price is a numeric variable. Okay, so I am taking the wines which has price less than 100. I'm just taking less than 100. Okay, so first let's check how many values are there whose price is less than 100. Okay, so I'll just execute this. You can see here there are around 1,33,770 values. So almost 88% wines has price less than 100. Almost 88%. That is a big chunk. 88% means only around 17,000 wines are there whose price is more than 100, right? So we'll just plot this part only. So it will be able to cover 1,33,000 values. And I'll just place a point now, plot dot his. So now you can see it has divided the entire range from 0 to 100 in 20. So 0 to 20, 20 to 40, 40 to 60, 60 to 80, 80 to 100. And even in this, you can notice that a major chunk is between somewhere around 15 or 15 $16 to hardly $40 in this also. So if let's suppose I'll take up to $40 only. So you can see here almost how many values are there. So let's remove this and see how many values are there up to 40. So 1,05,000. So a big chunk, more than 70% are there of 1,05,000. Okay, so yes, a big chunk has a price of less than $40. Okay, so by this you can check that how these things are working. So here you can see this. Now, you can see the price. So less than 70, you can see here how many values are there. Less than $70. Okay, so you can put multiple values and then you can see the price and you can plot them. So it's every or most of the things are same over here, and then you can apply their value counts in this part. So basically, the purpose of histogram is to divide the data, numeric data, into interval and then plot it on x-axis so that we can find the population in different ranges. Okay, okay,
Yes.
yes, okay. Now, next is bivariate. So, what is bivariate? Now, univariate was for single variable, bivariate is for two variables. So, when we have two variables to compare, we'll use bivariate, right? So, in bivariate, first of all, there is scatter plot, then there is hex plot, stacked bar chart, bivariate line chart. We'll see one by one what is this. So when basically we have to compare the relationships between two variables, then we use the bivariate. So what do I mean by relationship? When I say relationship, what is the meaning of it? Can you tell me? tell me, Sharmila, what do I mean by relationship between two variables?
Relationship between two variables. If you have two variables and then we are doing some calculations with that two variables.
No, here we are not doing the calculation with two variables.
Hmm?
Here what we are doing is we are basically um, finding how one variable is affecting the other variable. Means a variable, the behavior of one variable with respect to the other variable is known as relationship between two variables. Understood?
Yes. Mm-hmm.
Sorry.
Yeah, I understand, but if you show any examples, it would be.
So example means you can say if a variable of one variable is increasing, does the other variable is also increasing? If one value is increasing, other value is also increasing. That's what we called as positive relationship. If values of one variable is increasing and other variable is decreasing, we can say that is the negative relationship. Understood?
Okay. Yeah, yeah, got it.
Okay, so for example, when the temperature increases in India,
Mm-hmm.
right?
Mm-hmm.
When the temperature,
Your voice is breaking, breaking,
sorry.
breaking. Your voice is breaking.
So what I'm telling is for example, when temperature increases in India, the
Mm-hmm.
electricity bills are increasing,
Mm-hmm.
right? So temperature is increasing and electricity bill is also increasing. So what we say, this is a positive relationship. One value is increasing and other value is also increasing. So this is positive relationship.
Mm-hmm.
Okay. But
Yeah.
one value is increasing, other value is decreasing. So that is negative relationship. For example, sales of ice cream. No, sales of ice cream is mm, in sales
Yeah,
of ice
yeah.
cream
Same
or
example. If it is a rainy season in India, the sales of ice cream is just decreasing. It is a negative
hmm.
impact, right?
So,
Mm-hmm.
when one value is increasing, other value is decreasing, then that there is negative relationship. So with the bivariate plotting, we try to find out similar kind of things. So in that one is scatter plot. So what a scatter plot does is a scatter plot is basically finding the relationship between x and y. So here what I'm taking is price and points and trying to find if there is any relationship with price and points. So let's suppose we say that if points are higher, the price should also be higher. Is that the case? We'll check with the graph. So what we are taking, I am taking the reviews price less than 40. So I'm just taking the wines which have the price under $40. So we just saw there were around 1,05,000 wines were there whose price was less than $40. Okay, and those are taken. So price is on x-axis. So x-axis has price, and point is on y-axis. Okay, so this is on y-axis. Now you can see here there is one wine um, who has points around 86 and its price is also very minimum. Okay, here there are many wines are there whose price are around 86 and their price is going beyond 35. Okay, in the same way, you can see one wine is there whose price is around 96, 95, 96, who has 95 or 96 points, and price is around 24, $25. Okay, And there are many wines are there whose price is around 40 and they have got just $90. So we cannot find any pattern over here. We cannot, so when there is no pattern, so we cannot say that there is relationship between price and points. Can we say that? Okay, let's test it for price more than 100 so that less than 100. So almost 90% will be covered in this. So now here also you can see this is also not possible. Let's take for first 1,000 records. Okay, so in 1,000 records also you can see there is no such pattern is there. There are the wines whose price is around 60 to 65, and their points have only 85 points, and there are the wines who have got in 95 points and their price is around 2022. Okay, understood. So by this, we cannot predict that there is any relationship between price and points. Are you clear? Are you clear with this? So basically, this is the scatter plot. Next plot, you can see more thing in, like you can set the color in this, you can set the title in this. If you want, you can set some different color, like I have filling it with red color, so you can see red color points are there. So all these are cosmetic changes you can do with those cosmetic changes, and you can see how it looks like. So here there was no title and all. Here you can see I have set the title, the comparison of price and points, and it is coming over here, comparison of price and points, and it is clearly showing that there is no relation between price and points. Okay, next is hex plot. Hex plot is basically to find the density of the values in the range. Okay, it tries to find the density. So wherever density is there, the color will be darker. You can see here in this bar at the right side. You can see at 0 there is complete white color, and as soon it moves towards the higher number, it is becoming dark. So wherever there are the highest numbers, it has become dark. So in the graph also you can see here this point is for the most darkest point over here, and in this darkest point we can see how most values are there. So this point is around the means number of wines are there mostly around 87 points has the highest number of wines, and the price is around, so the price is around 20 to 40. So this is about 100. So it is no, this is price less than 45. So this is 918. So 9 and 18, it is somewhere around 17 $18, which has the highest number, and the points are around 87. And as soon it is moving away from this point, there are lot many other number ranges are there. So basically, you can see here if I reduce the grid size over here till 10. So what is grid size? So grid size is the number of these grids you are seeing. So here you can see there are earlier it was 15. So here you can see 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15. 15 grids can come in this. If I see this, do this 10, you can see here now this grids has become bigger in this. So only 5 grids are there now in this. Okay, so you can increase grid size, you can decrease grid size based on your need and based on how you are implementing. So now I have given grid size is 20, so it is giving that if you can do this 95, so you will be able to see more things in this. So you can see here how many things are there in this. So it was looking good with 10, most visible. So you can see here. Okay. Then stacked plot. So what stack plot is doing is Stacked plot are basically to show the numbers together on a single bar. Okay, so I'm taking a new data over here, and here this data is just a summary of wine data, and here it is getting top five variables, and now I am trying what we are doing is we are implementing them based on bar, right? So here for this also I have represented this plot dot bar, right? Now why this is only plot dot bar. So earlier when I was using plot dot bar, it was showing the different bars, but here what I have done is stacked is equal to true. So suppose if I remove this stacked is equal to true part and I execute this, so you can see here it is showing me different bars for each field. So there are six fields are there in this data: points, Bordeaux, Cabernet, Carni, Pinot Noir, and Red Blend. These all are six fields are there. So it is showing a one tower for each field. Okay. And since I'm just taking the top five values only, so it is giving top for top five. If I take it for top 20, so there are how many rows are there? Or 20 rows are only there. So if I say it by top 20, so you can see here, it will show according to top 20. Okay. Now, if this plot dot bar I am taking, now when I do this as tagged is equal to true, so now what it will do is you can see here it is representing all the values on one another. So point has come at the lowest position, then Vortex has with orange color, Cabernet Sauvignon is green, Chardonnay in red, Pinot Noir is in purple, and red blend is in brown color. So like this, you can see here all these values are represented. Okay, okay.
Yes, Kaushilya.
Okay, so it is showing one tower for each row over here. So you can see here there are 20 rows are there. So it is showing one tower for each row, starting with index 0, 1, 2, 3, 4, 5. One tower for each row. So like this, you can implement these, and you will get the univariate bar chart with this. Okay. Then the same thing is to be represented using the plot line. So you can see now we can represent the same thing using the line chart. Okay. So this is the line chart, and the same I am using instead of line, I'm using area. So it is representing the line chart. Okay, so bar chart, line chart, and area chart are almost same. Okay, just visible no, visual differences are there. In background, data is same. Okay, now bivariate line chart.
Yes.
So yeah. Now next is pair plot. So what is pair plot? Pair plot is basically to do the comparison for the variable. So now suppose I have this chart is sepal length, sepal width, petal width, and species. So this is this data, um, and I'm using this data for the pair plot. Right now, what I'll do is I am just taking SNS pair plot and iris data. With this was iris data, and I'm dropping this ID. Okay,
Mm-hmm.
why I am dropping this ID is because ID is nothing but just a count of it. Okay, so it is not going to affect anything our result, and even this is not the part of table also. It is just counting the ID like a roll number or employee ID like that. So which are not going to make any effect on any kind of decision making. So I'll drop that column. So I have dropped this ID, and then pair plot is being activated. So pair plot is basically part of SNS Seaborn package. Okay. Now here you can see we have got this. Okay, so here you can see here all the variables are being compared with all other variables. So in length, in the x-axis also you can see sepal length, sepal width, petal length, petal width. Or at the y-axis also you can see the same variable, petal length, petal width, sepal length, sepal width. Okay, so all the variables are being compared with every other variable. Now you can see here there is a diagonal part. In diagonal part, you can see this is bar chart is coming. So why bar chart is coming? Because you can see here if this one is there, this petal width is compared with petal width. Petal length is compared with petal length. Means these diagonal part values are just for just comparison with itself, right? So when there is comparison with itself, there is no use of it. So we'll avoid this. Now you can see there is one lower triangle and there is one upper triangle, right? So when I say lower triangle and upper triangle, you if you just try to transpose the lower triangle part, it will become the upper triangle part. So there is it is very similar to each other, right? Very same. So this graph that you are seeing is same as this graph. Okay, in the same way, this graph you are seeing, just notice my mouse. So this graph is similar to this graph. And so like that, these are the two graphs, two representations of there for each part. So we'll skip one of it, either upper triangle or lower triangle will skip. Okay, so let's see just the lower triangle only. So here you can see sepal width with sepal length, petal length with sepal length, and petal width with sepal width. So you can see here, we cannot see any relationship with sepal length and sepal width, but we can find some relationships with petal length and sepal length. In the same way, we can find some relation with petal width and petal length. You can see here, this is this graph. You can see here some kind of trends are there. Are you able to observe that?
I don't understand which triangle is similar to. We can leave. You said we can leave the upper triangle. What is that triangle? Can you explain again?
Yes, sure. Let me make it more visible for you. So you can see this diagonal part,
Mm-hmm.
uh, right? In diagonal part, there are bar chart are there. So if you see this one, this petal width and
Mm-hmm.
petal length. This is petal width with petal width.
Mm-hmm.
This graph, this is petal length with petal length.
Mm-hmm.
So basically, the bar chart part is comparison of variable with itself.
Mm-hmm.
Okay. So when there is itself, there is no point to compare the variable with itself. Okay. When we are talking about comparison of two variables, we cannot make any sense of comparing the variable value with itself. Okay. So just avoid this part.
Okay.
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 Now there is you can see there is lower triangle means that the
Below the
um,
bar chart part.
below the diagonal and above the diagonal.
Okay. Yeah. Mm-hmm.
Okay,
Got it.
so
Mm-hmm.
you can see here this graph and this graph is
Mm-hmm.
looking same.
Which graph and which graph? The-
Just see my mouse location. This graph. Can you see the mouse my mouse moving?
Yes. Yes. The first one and the
This
second
graph
one.
and this graph.
No.
Can you find difference between these two?
Yes.
Um, there is no difference between these two graphs. They are just transposed. Let me show you. So this is sepal length and this is sepal width. So this is
Mm-hmm.
between sepal length and sepal width. Okay. And see this. What is this? This is sepal length and this is sepal width. So this is all. This graph is also sepal length and sepal width. Understood?
Mm-hmm.
So this graph and this graph are both are the comparison of sepal length and sepal width. Okay,
Mm-hmm.
understood?
Mm-hmm.
I cannot
Yeah.
hear you properly.
Yes. Yes. Yes.
Yes, so this graph and this graph is same.
Which graph and which
Okay,
graph? The first
see
one
my
and the
mouse
second one.
movement. See my mouse movement. The
Yeah.
first graph
Sometimes
in
it's
the
your.
second row, first
Mm-hmm.
graph in the second row, and second graph in first row. Both are same.
Same.
In the same way, third graph in first row and first graph in third row. Both are same. This is same. This is this and this is same.
Mm-hmm.
Okay.
Yeah.
Yes.
Yeah. Yeah.
So in the
Diagonally,
same way,
everything. Same.
so below the diagonal and above the diagonal, graphs are repeated basically.
Yes. And it is
Understood?
also diagonally, everything is same from the
Yes.
beginning. Yeah.
Yes. So basically, when below diagonal and above diagonal are same, so we don't need to see the both graph and analyze. We only need to see either the upper triangle means below the diagonal or above the diagonal. Any one
Okay.
of them we need to see.
Okay. Okay.
Okay. So
Mm-hmm.
what we'll do is just see the graphs which are below the diagonal.
So how you say this scatter plot and then the bar chart in the upper part, the first row, first two graphs are same, you are saying, right? How you are
Hmm?
saying these two are same?
Graphs are same. You can see here. Just comparison on between which these graphs are plotted. This is between sepal width and sepal length,
Mm-hmm.
right? And this is also between sepal length and sepal width.
No, no, I'm not asking that one. I'm asking the first bar chart and then the next one. Very first one, very first bar. Yeah.
Bar chart and then
Then and
this
then
bar chart.
not the bar chart. I'm telling the next one, next the scatter plot one. You said the both are
Not saying
same.
I am not saying these both are same. I am saying this one. The
Okay,
first graph in the second row and second
okay.
graph in the
Yeah,
first
yeah,
row.
those are same. I understand. But initially, I felt I thought you are saying both are same. Those those are not same. That's why I'm asking why you said both are same. Okay,
No, I did not say that both are this first
okay.
graph is same.
Then fine. Then fine.
Hmm.
Then fine.
Okay, so now just focus in the on the
Mm-hmm.
graphs which are below triangle.
Mm-hmm.
Okay, so below triangle, now you can see this first one. We cannot find any pattern in this graph. Do we?
Mm-hmm. Yeah, pattern it is
No,
going up by 4.5, it is going up and then coming down by 3.5 and then again it's
no
slightly
definite
increasing.
pattern in this in this part. You can see here, this is sepal length and sepal width. So, sepal length and sepal width are at downside also. There are at higher prices, and at higher sepal width, it is the downside also. So we cannot see pattern going.
Okay.
See, you
Mhm.
see this petal length and petal width. It is consistently going towards up.
Yes.
This one.
Yes.
Just give me a second.
Mhm.
Okay, so you can see a definite trend that it is going towards upside.
Yes.
In this petal length and sepal length, you can also see it is definite trend going upside.
Yes.
But we are not finding any such thing over here.
No. No. No such premium.
Not in this also, not in this also, and not in this also,
Mm-hmm.
right?
Yeah.
So
This one
basically,
it's
only
going up, right?
this is somewhat it is going up, but not
Mm-hmm.
very much concentrated. Here you
Yes,
can see how
correct.
much concentrated it is. Here it
Yeah.
is much concentrated,
Yeah.
right? So we cannot find any definite relationships over here. So
Mm-hmm.
we can say there is relationship between petal length and petal width, and petal length with sepal length. There is definite
Mm-hmm.
relationship. The same thing we can represent with the different colors. So by specifying the use, and here there is different kind of palette is there. With that's what we are specifying, right? So basically, what we are doing is we are specifying the relationship between two variables. So this relationship is called correlation, right? So correlation between these variables is being found with these graphs.
Mm-hmm.
Okay.
Mm-hmm. Okay. No
So,
relationship.
um, what is correlation coefficient? We'll see the coefficient in further. There is a correlation coefficient is also there.
Mm-hmm.
Yes, we'll see how to calculate the correlation coefficient with here. We'll see that in short while. Okay. So this is about the bivariate. Now next is multivariate, where multiple variables will be involved. So for multivariate, we are taking a this football data.
Mm-hmm.
We are importing this data set. Let me run this. Give me a second. I'm getting a call.
Okay.
Sorry, there was an important call. Hello, hello, are you there?
Yes, no problem.
Um, Okay, so here now we can see here df.info there is 17,981 entries, and overall there are 73 columns are there. Now we see there is multivariate scatter plot we are taking. So footballers position value count. So if you know something about football, so there are various positions are there. So like a striker, goalkeeper, left winger, right winger, and left middle, left backward, center forward, like that. So many positions are there. So
Mm-hmm.
now it is counting how many players are there for which position. So simply it is giving the count of each position. And now we are trying to implement this on value and overall, and who is giving by is going to give by position, and just we are taking a striker and a goalkeeper only in this, and we are trying to represent. So you x on x-axis there is value, y-axis there is overall. So if you see the data, there are value, there are things like you see this is the value, this is value, and there is overall. So value is how much amount is being paid to them, and overall is the overall performance points are there. So we are trying to compare whether the value and overall ratios are perfect or not. So based on that, we are trying to do comparisons. So value are placed on this x-axis, and overall is placed on y-axis. Okay. And with this, you can see here striker, just a striker and goalkeeper are there, and they are being plotted. So you can see in this graph that value, the overall points are being started directly from 40 or 50, 40, um, approximate around 45 points are getting started. And value for many players it is at zero also. So many players are there who are having very low pay, and as soon the value is crossing the 70, eventually the as soon the overall points crossing the 70, value starts increasing, and there is some relationship. You can see there is a kind of line is there in this relation, representation. Okay. Okay.
Okay.
Okay, in the same way, you can see here, if I'm taking the third one over here, and so striker, left winger, and right winger. So there is a third color is also there that is represented. Then you can do the different markers also. So these markers are there: zero, X, and a star for a striker, left winger, and right winger. So you can see here it is representing which one is which, based on the marker you can identify. So you can see three parameters we are using over here. Okay, so these are some basic level plottings are there with this with this parameters. Just have a look. I guess this you won't be able to do on Notepad. I'll convert this file into NumPy and I'll share with you. So just you can see the code, but you won't be able to see this output in the normal Python format.
Why so?
Because these are the graphical representations are there in graphical representation. For that, you need a platform.
Okay, so where I can execute this code then?
On laptop only means you you told me you can see in your mobile. So for mobile purpose, you won't be able to see many things in this. But
No, no,
you can
no,
see the
no, no.
code in your mobile.
I can, I will try every each and each codes in Jupyter Notebook. So is it works on Jupyter Notebook, right?
Yes, yes. This is Jupyter Notebook only. It will work on
See,
very fine with perfectly with
I
Jupyter
will
Notebook.
see on mobile means sometimes I will see on mobile and then other time I'll carry my laptop too with me. So that's fine. I most of the time I'll watch and I'll